Hey, it's Rosa, and I'm just going to jump right into this informatory session on biochemistry. Let's start basic with two categories, inorganic and organic, more specifically in relation to compounds. Inorganic compounds are things like salt, carbon dioxide, and chalk. Organic compounds, on the other hand, contain significant amounts of carbon and relate more to our human body and its processes. When organic compounds are being formed, so are the functional groups that give them their unique characteristic reactions. These groups can be interchanged to alter the characteristic reactions of a compound. Furthermore, organic compounds form polymers through dehydration synthesis, a process the previous presentation informed you on. Some important polymers are carbohydrates, lipids, proteins, and nucleic acids. From previous knowledge, you should know that these compounds are pretty important to your functionality as a life-sustaining organism. If we didn't have chemical reactions, we probably wouldn't be here today. It is also important to know that there are different types of chemical reactions. These include decomposition reactions, synthesis reactions, and exchange reactions. In decomposition reactions, a large molecule breaks down into two or more smaller ones. In synthesis reactions, two or more smaller molecules combine to form a larger one. In exchange reactions, two molecules exchange atoms or a group of atoms. This is much like how atoms of a functional group can be interchanged. Reactions occur when molecules collide with enough force and correct orientation. Factors such as concentration, temperature, and catalyst can govern the speed and direction of a reaction. In relation to the body, all chemical reactions are termed metabolism and are subclassified as catabolism and anabolism. For example, oxidation is a metabolic reaction. It occurs when there is a loss of at least one electron when two or more substances react. Oxidation in the human body damages cell membranes and other structures like lipids and DNA. Oxygen metabolized in the body creates free radicals, and while the body needs some to function effectively, an overload can be linked with negative side effects. Oxidation of one molecule is always accompanied by the reduction of another. Reduction is any chemical reaction in which a molecule gains electrons and energy. Oxidation is also present in the process resulting in radiation. Radiation sources like X-rays and nuclear decay destroy molecules and produce dangerous free radicals through the process of oxidation and ionization in human tissue. Ionization is not caused in some forms of radiation, like UV light, but still has the same negative tendencies. There are many risks from radiation exposure, such as cancer, which will be further expanded on in the next presentation, as well as further insight on radioactivity.
Created using Powtoon.